Hello, everyone. This is Nayiri from Low Carbon Fasting. We have a professor of physiology and biochemistry with us today, and I'm delighted to have him on board with us. I'm going to let him introduce himself to you, but he's been a lecturer of physiology and biochemistry, from what I understand, for over 20 years. He has expansive knowledge of human nutrition and physiology. Professor Bart Kay from New Zealand, welcome to Low Carbon Fasting.
Well, thank you very much for having me. It's absolutely a pleasure to be here. I just do need to let you know that the internet connection doesn't seem to be great. So if we're stumbling around a little bit trying to get a message through to each other, that'll be why. It's the internet. It's out of our control. All right. So yes, by way of introduction of myself, yes, as Nayiri said, I entered academia some 25 years ago or so, and in that time I have specialized in really 4 areas. They are in no particular order: the physiology of rest and exercise, in other words, sports science with a physiology focus. From there, human nutrition / biochemistry / that kind of side of things. From there, cardiovascular pathophysiology, which is why do we get heart disease? Why do we not get heart disease? What's all of that about? And overarching all of that is a significant expertise in pure and applied statistics, statistical inference research methodology, that kind of side of things as well. So I'm kind of a hardcore empiricist, if you like. I'm known around the YouTube as being very gruff, very abrasive. It's a persona. I do it for clicks. It works. I'm not going to change it while it works. But it's all about, who's wrong on the interwebs and putting people straight where I believe they've made errors of interpretation, or where they're giving bad information to people as regards mostly human nutrition and exercise programming is the 2 things I kind of focus on. So yeah, that's me. I spent 20-something years doing that. Have a number of peer-reviewed publications, have undertaken a number of multi-million-dollar external consultancies over the years. Unfortunately, it's the university that gets those multi-millions, not the person doing the work. I just got a salary, so I'm still not a millionaire. So do feel free to support the channel by way of your subscription and merchandise and all of that kind of stuff. So that gets that out of the way. Anyway, yes, let's do this.
Okay. Well, you have expansive knowledge of physiology. Why don't we start with calories? The human body understands nutrients, hormones. Does the human body understand calories?
No, not at all. In fact, if by understand, if you mean do calories play an important role in determining someone's body composition, then the answer has to be a qualified no. And the qualification is that people often use the word calorie to refer to energy. Now, a calorie is a measurable phenomenon. It has an absolutely explicit, absolutely clear scientific operational definition. There is no question what a calorie is. Energy, on the other hand, is a construct. It's an idea. It's a concept. It cannot, in and of itself, be measured or gauged. There is, in fact, no externally valid, verifiable scientific operational definition of what energy even is, other than people in the know will say energy is the motive force to achieve work. And then you start chasing that rabbit hole and you go, okay, great, what's force? What's work? All of those things have circular definitions that lead you back to the same place. This is not something that we can get at objectively. It's an idea. On the other hand, a calorie does have that definition. It is the change in temperature of a water bath of a certain volume, starting at a set temperature in the first place, under the influence of rapidly combusting a sample of something inside a closed thermodynamic system known as a bomb calorimeter. And that's what you get. You put a large electrical current through the sample of whatever you're combusting. You rapidly vaporize that completely to carbon dioxide, water, and a bit of ash. And you get this release of photons, which are what makes up what heat is. They are photons. Those photons go out from the point of that combustion. They encounter the walls of the bomb calorimeter. They excite the walls of the bomb calorimeter. Then the bomb calorimeter gets excited by that and it passes on some photons, which then heat the water. So a calorie is the change in temperature of that water bath caused by those photons. Okay. Your body composition is made up of matter. It's made up of mass, actual physical stuff. Now, I get that there's a question as to whether physical stuff even exists. That's for another day. Let's just assume it does. What we do know is that the exact mass of a photon, the rest mass of a photon, is none at all, zero mass. So you cannot get fat by absorbing photons. If you could, we could go and lie in the sun and become obese. We don't do that, do we? No. Your body composition is a mass balance activity. It's the balance of mass taken in various forms: water, protein, fats, carbohydrates; mass stored: proteins, minerals, carbohydrates, fats, water. And your body composition, ergo your weight, your mass, if you like, your total mass, is a mass balance issue, not an energy balance issue. The form of energy that humans use for metabolism is chemical, not heat. So calories as a gauge on energy intake, storage, or utilization by the human body, totally inappropriate. Sure, heat and chemical energy are different forms of energy. One is kinetic, heat, the other is potential, chemical. And you can change energy from one form to another, absolutely, as per thermodynamics. We understand that. However, your body can only use chemical energy for metabolic process. We cannot encapsulate heat and use that. It's like going into a shop in the UK with New Zealand dollars and throwing them your New Zealand dollars across the counter and saying, sell me a bottle of water, for example. They will say, well, no, sir, that's not money here. I say, well, it's money. Yes, sure, it's a form of money, but not here. And that's what we're talking about. It's conceptual. So that's, I know, very long-winded, but basically that gets to the full detail of it. Calories do not gauge or even get close to approximating what goes on energetically in a human body. So we're done with calories. They're useless.
Yeah, that's the calories in, calories out, completely debunked in literally 2 minutes. And that's one explanation I haven't heard before. So it was beautiful to combine chemistry there. So no one ever talks of it, right? And I think people are just using calories to mean energy. But you explained
But energy doesn't mean anything
thing.
either.
Oh,
yeah.
Well, there you go. Okay.
Yeah.
So why do people put on weight? What's happening? There's an imbalance there somewhere.
It's a mass balance exercise. So there are many different ways in which I could change the weight of my body. Weight is the force exerted on a weighing scale, for example, by the mass of the body under the influence of the curvature of space-time that we think of as gravity. Okay. Gravity is a pseudo force. It's not actually a force, it's actually curvature in space-time. And that's what causes it to occur. Nonetheless, to all intents and purposes in everyday life, it can be thought of as a force because it acts exactly as a force, although it's not one. It's for another day. Don't get tangled up over that one so much. Anyway, the weight of my body is made up as follows. Some water, mostly water, in fact, because it's 65% or so water is my body. Some protein, most of the rest of that 35% that's remaining, in my case, because I've got very little stored body fat. There is some stored body fat on my body, and some people's bodies have more than others, absolutely. Then there's the weight of my skeleton as a discrete thing, my viscera, my organs, all of that stuff, etc. So they're all components, if you like to think of them that way, that are all independently moderatable, some quickly, some less quickly. And if I change all the different components of the weights that make up my total mass, that will have probably some effect on my total mass, unless they're all balanced out, in which case there'll be no effect, right? For example, I could put on 1 kilogram of lean muscle mass, take off 1 kilogram of fat off my body, and that has had no effect on my weight. So I might think, well, that was a waste of time and effort. Then I've achieved nothing. Well, it depends. Was my goal to weigh less on a scale, or was it to improve my body composition? Because I certainly did that. Here's another example. If I want to lose up to 0.5 kilogram within less than a minute, here's what I can do. I can go urinate. That'll do it. Water is not only the most abundant part of my weight, it's also the heaviest by volume of stuff, because water is very heavy. I could dehydrate myself over several hours. I could go and sit in a sauna. That would change my weight. I could surgically remove all my limbs. That would change my weight rapidly, quite a bit. Is that a good idea? No, I'm not suggesting it is, but I could do that. What we need to get out of our heads is this idea that our weight on a scale is important. What's important is how your body is composed. The relative amount that is protein, water, fat, skeleton, viscera, that's what's important here. Those are the things that are moderatable by moderating your diet appropriately and your exercise appropriately, basically. That's the thing that these idiots refer to as calories in, calories out. It's got nothing whatever to do with calories. It's mass balance.
So you did mention earlier on about changing each of the components, which we can do, right? We can change the water component by dehydrating ourselves, for example. How do we, I'm interested to know how one can change their skeletal mass, like bone density.
Excellent question.
Is that the same thing? Bone density and skeletal mass are the same thing?
There is a thing called, there is a thing called Wolff's Law, W-O-L-F-F, Wolff's Law. And it says that a skeleton that is subjected to X number of impacts per day will increase its density, in order to become more robust, in order to withstand impacts. So if I go outside to the shed, I've got a sandbag hanging out there that I train with sometimes, and I take a long bone, any long bone I like, let's say my humerus, and 12 impacts a day at reasonable force is enough to stimulate Wolff's Law, and that actually makes my bones denser, stronger, harder, there is more bone material and less space. After Wolff's law, those tissues react to that challenge, that training. So my skeleton would become heavier. So that's one way I could do that. Here's another way I could change the density of my skeleton. The inverse. I could become completely sedentary, and then my bones would start to dissolve slowly over years. Because people often don't think of their skeleton as a living, breathing organ. It absolutely is, and it absolutely can. I mean, how do you think bones repair themselves when you break a bone? They're living, breathing organs with a blood supply, and they absolutely can and do change their size, their shape, their density, and their weight. So, yeah.
So exercise
is
a good way to strengthen bones. How about protein?
Protein is important, not just for its ability to help you strengthen your tissues variously, be those skeletal tissues or various organ tissues, muscle, whatever else. In the absence of taking in any significant amount of carbohydrate in your diet, which is what you should do, you should not consume carbohydrates. None, ever, actually. It is important on a daily basis to get a bolus of protein into you in one meal, in one hit, that is sufficient to kick your insulin system into action and cause, think of it as a bump, not like a spike that you get from eating carbs, because that's bad. A bump. That bump, what it does, among other things, is it causes your kidney tissue to remain viable and to retain its ability to filter electrolytes in and out of your blood and maintain your electrolyte balance. If you intake insufficient protein, and or you don't have one decent hit of protein in a day, one meal of protein that's big enough to get that bump happening, what will start to happen is your kidneys will become leaky and you'll start to lose all your electrolytes. And then you'll end up with palpitations, muscle cramps, all sorts of problems. And then what you'll do, quite sensibly, is you'll tune, not sensibly, I'm being sarcastic, is you'll tune into certain other people's channels that tell you that pouring honey and sugar down your necks every day is a good idea.
Well, as a type 1 diabetic for 44 years, or 45 in fact, I know what honey does. I use honey to treat a hypoglycemic event. I used to, I don't anymore. I just use glucose tabs, but I used to use honey. So it's very, in fact, even piece of fruit can do the job just as well. So yeah, I love it that you mentioned the bumps and, you know, so you get a bump with a protein. I get, as a type 1, in fact, other diabetics might relate to it too, like type 2 diabetics. So we get a little bump, but not a massive spike, little bump after a protein-rich meal in our blood sugar. So anyone wearing a CGM like I do will notice that. But that's normal, right? That's part of our body building itself, building muscle, right?
It's not only normal, it's absolutely vital that it does occur at least once a day. Otherwise, you will end up with electrolyte problems and you'll end up with thyroid problems as well. This whole idea that you should be in ketosis all the time, and the deepest the ketosis, the better. And, oh, I better go on Facebook and ask, oh, will this kick me out of ketosis? To which I always answer that question with, I hope so, because it's meant to. You know, the goal of a ketogenic diet is not to be in ketosis. Ketones are not the goal. I wish they'd rename the diet. I mean, it's called the ketogenic diet because one of the ramifications is that ketones are present at various times. It's not the goal. It's not why you're doing it. And people that say that it is, oh, and maybe we should go and buy some exogenous ketones to take. Are you stoned? What? No. Anyway, that's for another day before I get off on that one. But yeah.
Okay, so when there are both fuel sources in the body available, like ketones and a small amount of glucose, say. So what does the body do in preference? Burns the glucose first?
Okay, so ketones are energetically favorable to glucose. And as such, while ketones are present, they may or may not take precedence over the glucose in various different tissues at different times, depending on the particular energetic state of those tissues. And when I say that, you know, there might be two cells which are geographically right next door to one another, one of which is using ketones preferably, and one of which is using glucose preferably. It depends, there are individual set points in individual cells even. It's a very, very complex thing, such that overall, the overall body, you can still say, yes, ketones are being preferentially used here, or glucose is. We can put radio traces on ketones and glucose to see what's happening, and we can use magnetic resonance spectroscopy to track these things in real time at millisecond time resolution, if we've got too much time and money and research funding and, you know, the desire to do that. At the end of the day, the human body is a remarkable piece of machinery with incredible homeostatic mechanisms to keep everything under control. And as such, it's going to do that. The rate at which ketones are being produced by the second and added to your blood are largely, the biggest influencer on that is the blood glucose level. So it's almost like ketones are produced when glucose drops below a certain set point. And that set point is trainable in an individual. It's individual between different people at baseline. And it's also trainable. You'll notice that once you've been doing a ketogenic lifestyle for several years, you will get into ketosis more rapidly than someone who's going the first time around, for example. So there is all of that. So, I mean, the short version of the long answer is that ketones are energetically favorable, but that doesn't mean they're going to be used first. The body will work out what it needs to use in what order, and it will go right ahead and do that without any input from us, pretty much.
Okay, so a lot of people don't eat sufficient protein because they're worried, and I'm talking about people in sort of our space, in the low carbohydrate space, right? Because they're worried about gluconeogenesis.
Yeah, exactly. Well,
what's happening there? Should they worry?
Well, no, they shouldn't, is the short answer. Absolutely not. Consistent with not eating ridiculously too much protein, which I challenge you to do ongoingly for more than about a week at a time, and see if you can even do it. Because it gets to a point where your body will send you such powerful, not only satiety, but actually revulsion signals, that it will stop you from doing that. You will not be able to overeat on protein ongoingly. Your body will not allow that. It's not silly. Your body has evolved over, well, at least 3,800 million years. It really knows what it's doing pretty well in that regard. The thing with the gluconeogenic effect is that's partly what's responsible for that insulin bump that we were talking about earlier. I mean, certain amino acids have a direct effect on insulin release without reference to producing sugar first, yes. But if you eat a bolus of protein that is sufficient, some of those amino acids will end up being deaminated and will end up producing a gluconeogenic effect, i.e. a very little sugar spike, and that will cause an insulinogenic response, and it's that which looks after your kidneys and your thyroid and all that kind of stuff, in the absence of taking in a meal containing carbohydrates, which you should not do. The caveat being obviously someone who is a type 1 diabetic who is under medical supervision, who has a prescription for how much insulin they're supposed to be taking, at what time, etc. That will be based on the diet that they say for you, this is what we want you to be eating. They'll tell you the wrong diet to eat and they'll prescribe you far too much of the wrong kind of insulin, but that's for another day. So I'm not suggesting that a type 1 diabetic should ignore that, because if you don't consume the carbohydrates that they imagine you're going to be, and you still take the insulin that they think you should be taking, you'll kill yourself. So let's make that caveat. I'm talking about, for the most part, as a generalized rule, the goal, the required intake, if you like, of carbohydrates for human beings is not 1 gram ever, whether you're a type 1 diabetic or not, in fact. So what would need to change if you were going to change to a carbohydrate-free diet? And I say carbohydrate-free because even meat contains some carbohydrate. It says 0 on the label because it's less than 1 gram per 100. It doesn't mean it's actually 0. There is some. Anyway, that aside, the goal is to get to a 0 carbohydrate diet and change your insulin to suit that, in concert with your medical professional. I use the word advisedly, your medical professional, Tihi. So that's what we're aiming for. The other caveat that is really important to understand, whether you're a diabetic or whether you're not a diabetic, it makes no difference on this one. Do not change your diet markedly from anything to anything else overnight. I'm going carnivore tomorrow. No, don't do that. Bad mistake. Change your diet slowly, glacially, over at least 6 to 8 weeks.
Yeah, I'm pleased you mentioned that, because you have a whole video, I think, about, or in one of your talks, you mentioned the keto flu and how the gut microbiome is not going to be happy. I think it's one of your older videos, but yeah. I've watched all of them. I don't recall this, which one it was, but you talk about how the gut microbiome isn't going to be happy if you decide to change your diet, even if it's a good change, positive change, a positive dietary change isn't going to be happy. It takes time to adjust to it.
Yes. Yeah, exactly that. Yeah.
So what exactly is keto flu when people first start cutting out carbohydrates? Is it just electrolyte imbalance, or is there something else going on there?
Yeah, I think there's several things going on. There's a disturbance to electrolyte homeostasis while your body adjusts. There are hormonal endocrine responses to the change in your food intakes and your energetic status. There are changes in redox potential of various different cells and tissues. And there is low blood sugar until you are able to produce enough of the enzymes involved in producing ketones rapidly enough to keep your overall provision of energy containing substrates in your blood at the right level. So that seems to be what that is. It's not a serious issue. It's not even an illness per se. It's more a physiological reaction. It will abate when your ability to produce ketones is up to snuff. It's not something to worry about. It's fine.
Shall we talk about, you mentioned type 1 diabetes, I mentioned it too. So, and a lot of people in my audience are type 1 diabetics. They follow me because I'm a type 1 diabetic who does one of the crazy type 1 diabetics who's constantly tweaking their insulin levels based on what they're doing, rather than having a set amount of insulin and then having to eat tons of food to match the food to the insulin. So, and I'm one of the crazy diabetics who also does fasting. So against my physician's advice, of course, because, you know, why not? If you can do it safely, why shouldn't a type 1 diabetic do fasting, as long as your precautions are taken? Anyway, I even created a Facebook group a few years ago because I got frustrated. I just wanted to find other type 1 diabetics who were doing fasting, and everywhere on social media, you'll identify with this. I got attacked, like type 1 diabetics, you shouldn't do this, you shouldn't do this. So I created a group. There are 200 over, in fact, 300 people now, 300 crazy type 1 diabetics who do extended fast like I do.
Awesome. Love it.
Yeah. Oh, thank you so much. So let's talk about the glycemic index, because that's one of your favorite topics, right?
Yeah.
Okay. So when people first transition to the ketogenic diet, they're very worried about the glycemic index, right? Okay. So you can eat, I don't know, you can eat carrots because their glycemic index is lower, or sweet potatoes because their glycemic index is lower compared to white potatoes, for example. So
Sure.
people are just constantly talking about the glycemic index.
Yeah.
To me, as a type 1 diabetic, doesn't make much sense, because whether I eat sweet potatoes or white potatoes or whole wheat flour or carrots or white flour like bread, right? I get a blood sugar rise. So to me, it doesn't seem to make much difference whether the food is low or high glycemic index. So take us through the glycemic index
Okay.
theory, if it is
so
a theory, I don't know.
Yeah. The glycemic index, or GI, is a piece of pseudoscientific crackpottery that was put together specifically by a group of researchers in the first place who were paid by people with an interest in selling you whole grains as good carbs, and funded this research. And what you'll find with scientific research in nutrition is that 98% or something of studies ever done agree with their funding sources. And they are couched and worded and put together in such a way. The idea of the glycemic index was to give people an idea of how rapidly a given sort of food is metabolized by the human body and how quickly it drops blood sugar into your blood, or glucose into your blood. The idea being that a food with a high GI can be expected to quickly dump a lot of sugar into your blood, whereas something with a low GI, while it might dump the same amount of sugar or more, does it over a much more extended period of time. It's a much flatter. So you've got high GI versus low GI sort of situation. The idea being that dumping a lot of glucose into your bloodstream rapidly is a bad thing because of the vast insulin response, thus leading to so-called insulin resistance, which is another construct, another thing that doesn't actually exist. And thus the sequelae of all of that, including type 2 diabetes, tending towards type 1 diabetes, inflammatory response, autoimmune response, heart disease, cancer, the whole lot, basically. So that was the goal, was to prove that whole grains are good carbs and refined grains bad carbs for that reason. Here's the problem. What they did is they took a very, very small number of individuals, not enough for great statistical power. And what they did is they got those people into the lab on a number of occasions, and they tested their blood glucose response over several hours after a given food substance. And they averaged those things up for that small group of people. And they said, so the average GI response, so what they do is they take the area under the blood glucose curve following a given food substance for, I think it's 3 hours or whatever it is. And so a very sharp spike like that gives you a lot of area under the curve. So the GI is a high thing. Now you need a comparator or a reference value, and some GI scales use white bread and some GI scales use pure glucose. They're slightly different. Which one do you think has the higher GI, by the way, if you don't know? of
White
pure
bread.
glucose and
Mhm.
white bread. White bread is higher than pure glucose in terms of its ability to drop glucose into your bloodstream. That's incredible, isn't it?
Well, when I was a child, I was diagnosed as a 5-year-old. So when I was very little, I remember when I used to have hypos. There wasn't glucose tablets back then, so mom would bring me white bread sandwiches to bring my blood sugar up.
Very quickly. All right. So let's say you get potatoes, boiled or baked or whatever it is, because they're slightly different depending on how they've been cooked. And it'll give you a value. You look in the GI tables and it'll say potatoes baked 68 or something like that, probably. I mean, I just made that number up. That's a guess of what potatoes are. And that's with reference to your white bread comparator. Okay. Here's the problem. What they don't tell you is that that average value 68 is plus or minus an error on the basis of where the different people came in. And that error is wider for one standard deviation than the entire value of the GI.
Wow.
In most cases. So that average value has an exact prognostic or clinical value to the generalized public of none at all. So to say potatoes drop glucose into the bloodstream more slowly than white bread is false. On average, on those few subjects, sure, maybe it did. However, some people will get a higher response to potatoes than they did to white bread. The average won't tell us that because the numbers can do this kind of nonsense. So between you and I, there could be huge differences and would be huge differences in how our particular individual bodies deal with a given food in terms of blood glucose release. So looking at the average value, worthless. The GI scale, worthless. And that would be enough for us to go, so the GI scale is of no value. However, it gets worse than that. If you take the same person and you get them in week after week after week after week, and you do the exact same test with the exact same food input, all else being controlled, same time of day, same everything else, same lab, same, blah, 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 pretty much. The difference between your response today, next week, the week after that, the week after that, and the week after that, also gives us this error, this huge error. So you can't even say that potatoes, you will have the same response to every time. The GI scale is an absolute have, and it's a have based on a statistical, using the averages and saying, look, the averages tell us that potatoes dump sugar slower than white bread. Absolute nonsense. Carbohydrates in the human body, when you take in exogenous carbohydrates in your diet, there is really only two outcomes of that. One, it will dump glucose into your bloodstream, or two, it will dump fructose into your bloodstream, one of those two sugars. Okay? Glucose, we know what that does. Fructose goes to the liver directly and is metabolized directly to triose or glyceride. So either way, if you eat carbohydrates of any kind, irrespective of what the GI value of that carbohydrate is, you will dump glucose into your bloodstream, or fructose, or both. It is contraindicated. You should never, ever do that. Consistent with the caveat I gave before about working with your prescriber of your insulin to make sure they get that right. And the answer is to adjust your insulin, not your diet. The insulin must suit your diet. Your diet is not designed to suit your insulin. Let's get that right. And if you don't already have the relationship with your physician that you need to have, then you need to either change that relationship with that physician or change that physician. And here is the relationship. You are in charge. They work for you. You say, doctor, I am doing this with my diet. You must now react to that and make sure you get my insulin dosage and type correct to suit that. Mm-hmm. That is your job. Your job is not to tell me how to eat. You are not trained in that. Okay? So.
Very true. Very true. Sadly, type 1 diabetics, we're kind of left. Type 2 diabetes, it's more acceptable these days for type 2 diabetics to be supported by their physicians. I think physicians are getting more and more excited about putting their type 2 diabetics into remission. But type 1s were kind of, we're the odd ones out. We're kind of left out. Oh, no, your case is too dangerous. So we're just doing it ourselves. And all it takes is a bit of confidence and knowledge, and you know, you're good to go. Adjust your insulin. And most people, most type 1s all over the world, at least the ones I'm in touch with, have a CGM or an insulin pump or pod like I do. And these are so easy to adjust. So the old advice of you must eat carbohydrates and take insulin to cover it is just gone. It didn't work. I tried it because Diabetes UK, the clinic, used to advise me to eat normal foods like normal people, like everyone else. And on the wall they had a poster of big wheat fields and corn. So that's what we were bombarded with. I couldn't match my insulin to the carbs. Anyway, that's my rant over. Okay, so let's talk about the fasting insulin then, because at a recent medical conference, I was, I think it was the San Diego one recently, I was there. They were even questioning whether that's totally accurate of someone's insulin production, because if someone is fasted for 12 hours or 16 hours, I think the minimum requirement is 12 hours to go for a fasting insulin test. Then sure, of course, your insulin is going to be low at that point because you're fasting. But if you eat, eat anything, how much insulin is your pancreas producing in response to that food? Now, that is something we need to measure. That was part of the talk. And it was the first time I actually got me thinking about fasting insulin tests being potentially useless.
Yeah.
Do you think?
Yeah. I think that, what we need to understand about measuring these kind of things is that unless you're using very expensive university-based laboratory type setups where you can radio label things so you know exactly what is being produced and where it's coming from and where it's going, the problem can be just taking the level may well give you false information, because the level of insulin in your blood is the result not only of how much insulin is being produced, but how much is being used to affect the role that insulin is there to do. So unless you know how much is being produced and how much is being used, then the value of the concentration, if you like, of the insulin in the blood is not really giving you much information. And it could lead you to false beliefs. For example, you might be producing and using insulin rapidly. And as such, your concentration of insulin might not change very much at all. And you might say, oh, look, I ate this bolus of food, whatever it was, and it had very little influence on my insulin. Well, maybe it actually did. And you could say, well, why not, in that case, measure the glucose as well in parallel with measuring the insulin? Well, great, that'd be better, except the exact same problem exists, doesn't it? Because the concentration of glucose in your blood is dependent not only on how much is being put in, but on how much is being drawn down by the various tissues. So without radio labeling those things separately, individually, and following them using a machine called a a magnetic resonance spectroscopy machine, which costs tens of millions of dollars to get one of, forget it. You're not going to get the information. It's not going to tell you what is occurring physiologically. It becomes a number for the sake of a number, is what I'm saying. And as such, not only might it not be useful, it might actually lead you to false conclusions. So that's why I would not be a fan necessarily of that.
Now, how about the HbA1c? Because that's not too accurate either. For example, my CGM, my average blood glucose, is completely different. It's a good figure, and yet when I go for my HbA1c, it's always, well, it wasn't when I first started the keto diet, my HbA1c dropped dramatically. It dropped down and I was like, oh, I'm in non-diabetic range. I was so pleased. And then gradually I removed plant foods. Now I'm a carnivore, or 99% carnivore. And my HbA1c keeps going up every time I go. So should I trust? And I do trust him, but Dr. Paul Mason, I'm sure you're familiar with him. So he was talking about the red blood cells potentially living longer, and therefore giving a false kind of HbA1c result. Why don't you give?
That's one possible thing.
Yeah.
Yeah.
So why is it that on a carnivore diet, where I'm feeling my optimal, I'm feeling healthier, I'm lifting weights, I do resistance training, I literally feel younger than I did 30 years ago. Why is it that my HbA1c keeps going up?
Yeah. Okay. So there are a number of things that play into that, a number of mechanistic speculations. For example, the red blood cells living longer in a carnivore population because you're not destroying them as quickly as you would with plant-based toxins and problems of that nature. Sure. The fact that your blood sugar is actually far more stable than someone who is not classed as diabetic but still eats in such a way as to cause their blood sugar to be doing that. So they can end up with a lower A1C than someone who has a more stable blood glucose level. I mean, you really said it yourself there that the main things to look at are, I mean, you're tracking your blood glucose using your CGM, and it's fine. So you know it's fine. So you know that there is something aberrant with that A1C reading. I would relax about that a bit, so long as it's within reason. There's also nothing actually anywhere in the literature that can suggest to us that a person who is eating an almost, if not completely carnivorous diet with an A1C 5.6 to even maybe up as high as 6, there's no evidence anywhere that that's actually problematic long term whatsoever. There's no evidence it's not either, by the way, let's be honest. But using the scale, the normative values, the predictive outcomes, risk factors for a normal standard diet eating, either diabetic or non-diabetic, as a gauge of your risk of anything is not going to be helpful, is not going to be useful. Yes, I do absolutely explicitly trust what Paul Mason has had to say on that and many other topics, by the way. And I agree entirely that, I mean, I think so long as your A1C is around 6 or below on a fully carnivorous diet as a type 1 diabetic, I think that's a fantastic result, frankly. And if you're tracking your blood glucose with a CGM and it's fine, then that's your answer. It is fine. You're testing it. You know it's fine in terms of the value in your blood at any given time. So also the thing obviously to avoid is any huge swings in your blood glucose. Keep your blood glucose as stable as possible. And I'll tell you what, a carnivorous diet mixed in with some fasting is a pretty damn good way of achieving that.
That's why I do what I do. This is exactly why I do. In fact, I even have to watch my fat intake. So it's not like the ketogenic diet that we're familiar with, high fat and, you know, moderate protein. It's not like that. I have to watch the fat because that's a big player in my blood sugar. So if I overindulge in fat, I'm going to have that, you know, slight bump you mentioned earlier. I'm going to have that slight bump go on for a good 24 hours. My blood sugar will come back down. If I reduce my fat intake, I don't eliminate fat, obviously, but if I reduce it even slightly, or I don't indulge in cheese, which is something so easy to do, I get stable blood sugars all day long. So I've had to learn that, not because my physician taught me, because I was, you know, through trial and error.
Excellent. All right, just to let you know, I think I've got about 2 minutes left because I do have another interview straight after this. So probably got time for one more before we close off.
I'm going to put all your links below, so we don't need to go over it. But can we very quickly talk about, we mentioned the carnivore diet, but can we also talk about the vegan diet and why it's not optimal for humans?
Yes. Really, really simple, really straightforward. The vegan diet is demonstrably, absolutely, unequivocally destitute of something like 15 or 16 different nutrients that human beings require pretty much on a relatively daily basis to do well and to thrive and to have robust health and longevity. There is no question whatsoever that the vegan diet is destitute of many, many nutrients. And as such, it is absolutely inappropriate to attempt to use that diet if health, longevity, and robustness of your life experience is your goal. It's that simple.
Thank you so much, Professor Bart Kay. Thank you for your time. I really appreciate it.
My pleasure. Thanks for having me. And hopefully we can do it again real soon. I'll have you on my channel for a return visit, and hopefully we won't be so pressured for time.
Thank you very much. Bye for now.